Now, so let's look at a similar example here. Example 2. Okay. Now, think about that circuit element. So we still have the same circuit element as an example. If the voltage difference between points A and B is 10 volts, between this point and that point, voltage equals 10 volts. And what we are looking at is calculating the amount of energy that's required to actually push through 4 coulombs of charge. So this is voltage difference between points A and B. Now, how much energy is required to move 4 coulombs of charge from A to B? So we require to calculate energy. Think about this relation. But we know that voltage equals change of energy per change in coulomb. So from this, energy equals voltage times charge. So our voltage difference is, the voltage difference is 10 volts times 4 coulombs of charge. So the energy required to push through those 4 coulombs from point A to point B, therefore, is 40 joule. So we looked at the common variables in a circuit element, which are current and voltage. But the discussion of current and voltage also gave rise to electrical energy, which arises from the separation of charges. Now it's worth to discuss a little bit more on this energy. So if we look at the first terminology that comes to mind in the discussion of energy, is the rate of this energy per unit time, which we call power, designated by letter P. So power equals the change in this energy that we discussed over unit time. We can calculate energy from this relation as D equals power times time. Now, if we can further investigate the relationship we've just defined here, this energy, we said power equals, so if we look at the first terminology that comes to mind, change of energy, per discussion of energy, change is the rate of this energy per unit time. If we can multiply this with power, with the following quantity, dE dt, multiplied by dq per dq, multiplying by dq over dq does not change the original meaning or value of your ratio here. Then we can then rearrange this as follows: dE over dq, taking this denominator here, okay, times dq per dt, taking that denominator to as a denominator on the second fraction. Now what we are saying basically is P equals dE per dq times dq per dt. But now we know that from our discussion of voltage, it is the change of energy per unit charge, so we already called this voltage. We also know what this variable is. That's the flow of charges per unit time, which was current. Okay, So we can now see that power equals voltage times current. So that's also one important relation that we need to keep in mind. So let's look at an example here. Now assume that circuit element we discussed earlier. Now let's this time assume that the voltage across this A and B is 5 volt, okay, and a current of 0.55 amps flows through the circuit, okay. Then how much power is associated with this circuit element? Okay, so solution is easy. Now although we have defined power to be the rate of change of energy per unit time, we also know power can be given by the product of voltage times current. So simply we have a voltage of 5 volts times in current of 0.55 amps, okay. So therefore the power associated with this circuit element for these given variables is 2.75 watt, okay. So the unit of power is watt, okay.
I think these videos are brilliant and I'm sure you will like them too. Please like, comment and subscribe, and don't forget to click the notification bell.